Okay. Here we go. So the vector product, different than the dot product. The dot product is a constant, right? The dot product is a constant. The vector product is another vector. Yay. Like I said with the right-handed rule, if you take your 2 pointer fingers and go like this, your thumb will always point in the direction of the cross product. Yeah? Yeah. All right. Here we go. Yeah, it's a lot of fun. All right. The vector product, aka the cross product. Notes. So, right. Of two vectors. So if you took the cross product of two vectors like u cross v, notice not a dot anymore, right? So u cross v, that's the same thing as multiplying their magnitudes. Instead of cosine, it's going to be sine theta to the normal. Now, not normal per se, because normal to a plane is like another concept, but normal to two vectors is a vector that's perpendicular to both vectors. So, like the normal plane is perpendicular to a plane. This thing, this n, is a vector perpendicular to both vectors. So, Alejandro, take your right hand, point your one finger, middle finger, thumb out this way. So your thumb is normal. It's like it's perpendicular to your other two fingers. True? Yeah. All right. So yeah, that n is a vector perpendicular to both u and v for the right-handed sense. It's not bad. I did put the little arrow. The other way you can see that n is n hat. Yeah. Okay. The circumflex looks like this, so yeah. It indicates that n hat or n circumflex is a unit vector in the direction of n. No big deal. No big deal. Couple of properties for cross product. If you take the cross product of u and v, that's the same thing as taking the cross product of negative v and u. So it's going the other direction. That'll give you the same thing. Okay? And this should look familiar. If you take a scalar times the cross product, then you could just take the scalar of one of them cross the other, and vice versa. So u cross scalar v. So you just have to apply the scalar once, which makes sense. Okay? Yay. All right, distributive rule. Here we go. For vectors u, v, and w, if you have u plus v, and then you're crossing it with some vector w, distributing each thing, you can do u cross w plus d cross w. Yeah. Yay? So, pretty simple rules. Okay. Here we go. If you take the cross product of your unit vectors, a pattern happens. There's a pattern that happens. So, the cross product of I cross I, since it's the same thing, their cross product is going to be 0. Right? And then I cross j will be k. And then I cross k would be negative j. If you want to see where that stuff came from, there's like a really long, drawn-out equation that they used in the book for it. But I'm just going over the pattern. I'm going to show you the shortcut. Yay? Yeah. Okay? J cross I is negative k, then 0, then I, then j, then negative I, and then 0. Yeah? Okay, so if you take those as your component forms with two vectors p and q, what would happen is, the ticker light comes, we'll take a break. All right, this is the long drawn out version that I'm pretty sure it's in your formula sheet, but if it's not, it's okay because it's just a bunch of IJKZM. So basically, if you take all those values with the negative I, j, and k, what happens is the cross product of two vectors becomes 2 times P2 times P3. So Q3 minus P3 Q2. So you go cross here, and subtract. Okay? And then the j component would be P3Q1 minus P1Q3. And then the k component would be P1Q2 minus P2Q1. And that looks absolutely horrible. True? All right. Let me show you where that came from. Yeah? Other than this right here, so basically all that's happening, for the I component, it's k minus the j. So k minus the j. And then for the j component, it's I minus k, and then j minus I. So here's what happened. Here's the quick way. Yeah? If you go I, j, k, oops, let me do this. Hang on. Pause. All right. So here's how they get that without having to memorize all of that stuff. Remember, we're taking the cross product, right? So if you do ijk, and let's say you go P1, P2, P3, and repeat. P1, P2, P3. And underneath, you go Q1, Q2, Q3, and again, Q, Here we go. Oh man. Fine. Delete. Okay. Q1, Q2, Q3, Q1, Q2, Q3. It's a cross product for a reason. So the I component, right? The I component goes like this. Is our highlighter? Yeah. Okay. So to find the I component, you go across this way and across this way. Yeah. Like that. You see it? So the I component would be P2, Q3 minus P3, Q2. Is that right? Looking at the top, right? So that's where that came from. Okay? So you just cross. It's that easy. Okay, and then and the same thing for J's, the same thing for K's. Yay, cross product. Okay. All right. Here we go. Last formula, and then we get down to the nitty-gritty stuff. Perpendicular distance from a given point. Okay, with position vector P and the line R, A plus TB is given by, if you take the magnitude, of the distance of the two positions, so P minus A, and then cross that the other point that you're, oh, sorry. Yeah. Oops. Nope, that's supposed to be magnitude. And that's supposed to be like that. Magnitude. Yeah. And yeah. Where you just take whatever B is, make it B vector. Yay? Okay. All right, let's practice. Here we go. First one's easy. What you list a little bit. Find the vector product. IJK, IJK. Yes. I just kidding. Yeah. 1, -3, -5. 1, -3, -5. And then 0, -1, -2. 0, -1, -2. Okay. So for the i's, the cross product is right here and right here. So -3 times 2 is 6. And then -5 times 1 is 5. Yay. For the j's go this way. So 0 and -2. So 0 minus -2. No? And last but not least, for the k's, did I do that right? Yeah. Okay. So -1 and 0. So -1 minus 0. Joy. Wait. Wait one. One, two. Shouldn't I have a 2 somewhere?
Wait.
Did I mess up?
I feel like we can do the opposite one.
Mm-hmm.
Start like if we're doing academic, so.
You sure? 6 minus 5 is 1. And then 0 plus 2 is 2. 1. Yeah, 1 minus 0 is just -1 again? Is that right? Lee? You sure? Yeah? Looks good? No. Oh, -1. Does that work out? Yeah? Yeah. Okay. All right. No big deal. Yay? Yay. Okay. The following formula is also in your formula book, finding the area of a triangle. You should remember a little bit from math analysis. The area of a triangle with reference to sine is equal to half side sine theta. So one of the sides would be like AB cross AC and then sine theta, which is the same thing as 1/2 the magnitude of AB cross AC. So if we just have to find the cross product of AB and AC, find the magnitude, take half of that, bada bing, bada boom. Okay. So AB. Okay. This B minus A, so 4 minus 1, trig. 6 minus 2, 4. Yeah. And 2 minus 3, -1. Yay. And AC. Let me hear it.
5, 6, 7.
It's all good. All right. So taking the cross product of AB and AC, again with IJKs, we've got 3, 4, -1, 3, 4, -1, 5, 6, 7, 5, 6, 7. Cool. Here we go. All right. I is 4 times 7, 28. Minus, yeah, plus. So minus -6, that'd be +6, right? J would be -5 minus 21. And then k would be 18? Yeah? Minus 20? Sweet. 34, negative 26, and negative 2. Is that right? Okay. So the area is half of the magnitude of that. So to find the area, that'd be half 34 squared plus negative 26 squared, and then negative 2 squared. Okay? And by doing math magic, that simplifies to 3 root 51. Oh yeah, unit square. Sure thing, Matt. Sweet. Okay. So far, so good. Questions, concerns? Good. Keep pushing forward. Okay. Here we go. Woo. Find the vector equation of the line of intersection of those two planes. All right. So, to find the vector equation, you need a position vector and a direction vector. Right? Okay. So, one, find the position vector. Yeah. The cross product of the normals. So here's the thing. All right. So the thing, we just kind of have to pick a point. Let's start with z. If you let z be 0, then you can pretty much figure out what x and y are. So we know it's going to be a line, and somewhere on that line z is going to be 0. Right. True? Yeah. Yeah. Okay. So if you let z equal 0, dot, 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 then like this would be just x minus y equals 5. That's a y. Right? And then 3x plus 2y equals 5. Well, if they're both equal to 5, then set them equal to each other. There's no need for a row reduction. Is there? No. Well, oh! Did I show you? You guys were gone when we did the GDC thing, right? The graphic calculator thing? Let me show you something real quick. Yeah. Yeah, RF. You guys were out giving Metter donuts. So let me show you that again. All right, got your calculators? I'll wait for you. Which, by the way, if this was a paper 2, it's perfectly acceptable to write GDC and then the answer. So, yeah. Yeah, paper 2. Yeah. Yeah. All right. So, see where x is the inverse, x is negative 1. Hit second matrix. And then we're going to go to edit. So go over to edit on that side. Right? You want a 2 by 3 matrix because this is your x, y, and your answer. So if you type in, yeah, oops. Okay. So if you type in 1, negative 1, oh, hang on. 1, enter. Negative 1, enter. 5. Oh, 2. Yeah. Negative 1. Negative? Ah, not negative. Nope. So negative 1. There it is. And then 5. And then 3, 2, and 5. Right? Did it work? Okay, sweet. So you go second quit, get out of there. Second matrix, math. go down to R ref. Come on. So that would be B. Yep. Hit enter. And then second matrix. Holy smokes, man. Yeah. Yep. Okay. Did you get it?
Yeah.
Yeah, I just put an A. And then so what's the answer?
X is 3 and Y is
Yes, sir. That's it. That's it. Yep. This thing is so messed up. Okay. Let me go back to this thing. Okay. Yeah. I wish that thing wasn't there. Okay. All right. So you get x is 3, y is -2. There it is. Yay. So you have a point of intersection of 3, -2, 0. So once you have a point, then your position vector is 3, -2, 0. Yay. Direction vector cross product. All right, so part 2, find the direction vector. So 1, -1, 2, cross 3. Where did the 1 come from? Oh, yeah. This is the direction vector of the cross product of the 2 original lines. So 3, 2, 1. What is it? Yep. -5, 5, 5, which has a scalar of 5. So really it's just -1, 1, 1. So this would be your direction vector. Yeah? So the equation goes something like this. R equals position lambda, mu, any preference, whatever, -1, 1, 1. Ta-da! So good. It's so good. Her. Good? Okay. Kirsten, good? Yeah? All right. Go. All right, so once upon a time, there was a point on the plane. That point had coordinates 2, 1, 4. And there was a straight line with the Cartesian equations, blah, blah, and blah. Okay? So, there's this point on the plane. 2, 1, and 4. Yeah? And then there's some line out here in space with that Cartesian equation. Yay? So if that's the Cartesian equation, to bring it back to a vector equation, so this is for you, Matt, right? To go from Cartesian to vector, if you just imagine there's a -1 here, that's your A, B, and C, L, K, and L, right? So the vector equation, the X, Y, and Z, I should say. Yeah. Delete. Yeah. X, Y, and Z is equal to 1, because it's subtraction. So x minus a, so a is 1, -2, and 1, plus lambda LKJ, or yeah, L something M, LMN? Yeah. 3, 5, 1. Yay? So there's a point on the line. So there's some point on the line right here that is 1, -2, 1. Yeah? And its direction, the direction of this line is 3, 5, 1. True? Okay. So we need to find find the Cartesian plane containing the point and the straight line. Okay, so we need to find the vector from this point. Yeah, this point to that point. Sweet. Well, finding the distances, this vector right here, since this is 2, 4, 1, that vector would have, just subtracting, would be, yeah, or -1, -3, 3, but yeah, 1, 3, 3 works. Yay? Yay. Okay. So the normal to the plane is, take the cross product of the two vectors. Again, our two vectors are this and this. So if you go, I don't know, 3, 5, 1 cross 1, 3, 3. You would get, come on in. Hi. Sorry? 80, oh, I don't have any. Sorry, thank you. Yeah. They want to do it? Okay. Yep. Yeah, I like it. Let's take out a 4. Absolutely. Which is the normal right here. So this is the normal to the plane. Right? So the equation of a plane is at ax, by, c, d, right? So the equation of a plane is 3x minus 2y plus z equals sum d. Yay. Plug in the point. What point's on the plane? 2, -1, 1. So if you plug in 3, 1, sorry, 1, -2, 1, right? So if you plug in 1, -2, 3 minus 4, wait, 3 plus 4 plus 1 is 8? Yep. So final equation, 3x minus 2y plus z equals 8. And they all live happily ever after. Almost the end. Yay. Yay. So, is there a pattern to like what you're supposed to find first? What's up? Yeah, so finding the normal, finding the cross product, and so on, and just realizing what the components of the pieces that you need. Yeah? Okay. Huh? Just feel it. Just feel that plane. Yeah. Okay. What? This is like a plane. This is like a plane, and my microphone is like a point. All right. Number 5 is really a common IB question when it comes to yeah, the IB exam. They like to use like capital pi. Have you ever seen capital pi? Yeah, it looks like Roman columns, right? As opposed to like little curvy pi. Yeah. It does? It looks like a what? Architecture thing? Yeah. Yeah. Alright, let's finish this now. Here we go. Two-parter. Part 1, find the Cartesian equation of the plane which passes through point P with coordinates blah, 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 and is perpendicular to the planes with equations blah and blah. What do we need? That's like the last step, because we're looking for the equation.
If we got the normals to both the planes.
Thank you. Yeah. Right. We have normals. What are our normals? 1, 1, 0, and 0, 1, negative 1. So as Genius over there was saying, take the cross product, right? Take the cross product. So a vector perpendicular. Seriously? Nick, you're killing it. Kill it, man. This is good. 0, 1, negative 1. I'm so lucky to have like someone who is like a vector expert. At least one person in every HL. Thank goodness, because I always get confused. It's all good. Yeah. It's all good. It's all good. Yeah. Find it. Sir. Excellent. Excellent. So negative 1, 1, 1. The Cartesian equation goes something like, so the Cartesian equation, yeah, goes negative 1 x, well, plus 1 y plus 1 z equals d. We have an x, y, and z. Yep, so negative 1 times 3 plus 1 times 2 plus 1 times 0. Oh boy. The negative 1? Yep. And so final answer, negative x plus y plus z equals negative 1. Yay! Oh boy. Oh my. Okay. Moving forward, last one. Here we go. Let L be the line in capital Pi, which passes through P. Oh, a line passes through P, which is perpendicular to OP, where O is the origin. Find the vector equation of L. What? We do need OP. Oh boy. We do need OP because now it's got OP. So the direction of OP. Yeah, we do. We had P before. Yeah, it's just part 2. Yeah, what was P? 320. So it's 320 minus the origin. So boring. Is 320 again? Why did they? Okay. Oh goodness. So by finding that is our position vector. Okay? We need a position vector and a direction vector. To find the direction vector, take the cross product to find the normal. All right, so here we go. Since L is in the yeah. That's part 1. Part 2. All right. As L is perpendicular to the normal to capital Pi, dot, dot, dot. take the cross product, 3, 2, 0, 3, -2, nope, 2, 0. And then we found the normal last time, which was -1, 1, 1. Go for it. Yes, sir. Alejandro, master of the cross products. Yeah? So this is our direction vector. Okay? Final answer. Position plus direction makes for a happy vector. The end. Yay. Okay. Kind of glad it ended like on today as it was, because the assignment is rather lengthy, and instead of 2 days to complete it, you have 4. Yeah, you got 4. Because I won't see you again until Tuesday. Yeah, I won't see you again until Tuesday. So you got the evens from this chapter, and then we're going to start looking at the exam questions, right? If we need a little bit more time, we do have that extra review day to go over that, because next time is a review day, so we're just going to go over these questions and make sure you're good to go for the test. It's good. It's good. All right. Nice to Don.
Wait, Matt, why are you